Okay, welcome back to our course that is breeding for crop improvement. Today we'll discuss about the lecture number 3 that is breeding for cotton. In breeding for cotton, we'll discuss about the economic importance of cotton, centers of origin of the cotton, and next here we'll discuss about the evolution of the cotton, how how New World cotton was evolved from the New World cotton. We'll discuss, and next we'll discuss about the important breeding objectives and the important breeding methods we'll discuss in this lecture. So here comes the lecture outline. Here we'll discuss about the centers of origin, distribution of the species, breeding objectives, conventional approaches, and innovative approaches. These are the some of the lecture outlines of this lecture we are going to discuss. And first we'll discuss about the economic importance of cotton. Generally this cotton is called as commercial crop. It is called as commercial crop. It is because per quintal, based upon the yearly the per quintal the cost will changes, the price will changes of this cotton, but most on an average it is having some around 8,000 to 9,000 rupees per quintal. So it is called as commercial crop like sugarcane. So this cotton is why this cotton from the major product we'll obtain from the cotton. This is the fiber. It's nothing but lint. This is the fiber which is used in which is used to make the clothes, which is widely used in the textile industry. So this cotton is having the more useful things about this cotton. So it is called as economic crop, and this cotton is called as king of fibers. The king of fibers is a cotton. So we'll discuss about general in common words, it is called as the cotton. And next is vernacular name, it is called as kapas. And the scientific name of cotton is it is a Gossypium herbaceum. And the chromosome number in cotton, we are having the diploids as well as tetraploids. The diploids are having the chromosome number 2n equal to 26, whereas the tetraploids are having the chromosome number 2n equal to 52. And it belongs to Malvaceae family. So this is about the some of the economic importance and some things about the cotton. So next coming to economic importance. So I told the cotton fiber is the major commercial product of the cotton. It is called as a commercial crop because the cotton fiber is widely used in the it is used to spun the thread and which is used to make the clothes in the textile industry. So generally per quintal it is having 8,000 to 9,000 rupees. So because of this it is called as a commercial crop, and it is also called as the king of fibers. Generally, the fiber which was obtained from the cotton is spun into thread, which is used in the textile industry. And next, here from the cotton, we will be having the secondary product and primary product. The primary product is the fiber, whereas the secondary product is cotton seed oil and cake, which are used as the secondary product. And here, the cotton seed mill is used to feed the poultry. So these are the some of the economic importance or uses of the cotton. That is the major. It is called as commercial crop, and the primary product of this cotton is the fiber, which is spun into a thread, which is used in the textile industry. And next is the secondary products are cotton seed oil and cake. And next is the cotton seed meal, which is used to feed the poultry. So these are the some of the uses of the cotton crop. Next, we'll discuss before going to in detail. We'll discuss about the crop of the about the structural parts of the cotton plant. First is here you can see here the roots. We are having the roots, and next is stem. Generally, in cotton, we will be having two different types of branching. One is monopodial branching, and the other one is the sympodial branching. What the difference between this monopodial and sympodial branching? Monopodial branching is nothing but generally the stem will bear only one or two branches, and it will be having the squares, some flowering it will have, and it will give only a few number of bolts. And next is sympodial branching. Sympodial branching is nothing but here you can see this is nothing but sympodial branching. Here you can see from the stem we are having the multiple branches, and on the multiple branches we are having the more number of flowers. These flowers are converted to square, and from the square we'll get the lint. Okay, this is the white color is nothing but lint. That is the cotton fiber. So these are some of the structural parts of the cotton. That is the root, stem, and the branching pattern is it is of two types: monopodial branching and sympodial branching. Monopodial branching, the stem will form only a few branches or one or two, three branches, and it will present only some flowers. And because of some flowers, it will give only few number of the bolls, and because of that, the yield will be less in case of monopodial branching for type of varieties. And next is sympodial branching. Whatever the cultivated species, now everything comes under the sympodial branching. Here the stem is branched into it is having the different more number of branches. So each number of branches are having some 4 to 5 number of bolts. So these bolts, after when it reaches to maturity, it will converts like a cotton fiber. That is, a cotton fiber is nothing but this is the lint. Generally, the cotton seed is having both. Sorry, this bowl is having both seed as well as the fiber. Generally, in each locule, there will be the seed which is enclosing with the cotton fiber. That is nothing but the bowl or the square. So these are the structural parts of the cotton plant. And next we'll discuss about the distribution. Generally, the major cotton growing states in India are Gujarat, Maharashtra, and Telangana. Whereas in coming to the Telangana, the major cotton growing districts are Nalgonda, Adilabad, Sangareddy, Nagar Karnool, and Komrambim. Now it is called as Asifabad. So, in case of in India, the major growing states are Gujarat, Maharashtra, and Telangana. Whereas in Telangana, the major cotton growing states are Nalgonda, Adilabad, Sangareddy, Nagar Karnool, and Komrambim. So out of all this district, the Adilabad is having a more area under the cultivation because this Adilabad is holding the more number uh, having more black soil. So the cotton growing district is mostly it is Adilabad in case of Telangana. So this is about the distribution. And next is we'll discuss how what are different types of cotton. Generally, the cotton is divided into two main groups. One is old world cotton, and the next one is the new world cotton. Old world cotton is nothing but these are the species which are diploid species which are having the chromosome numbers 2n equal to 26. These are the old world cottons which were cultivated earlier, which includes two different species, that is the Gossypium arboreum and Gossypium herbaceum. So this is about the old world cotton. This old world cotton, these are the widely cultivated earlier. So they are called as old world cotton, and these species are diploids, which are having the chromosome number 2n equal to 2x equal to 26. And here we are having the two species, that is the Gossypium arboreum and Gossypium herbaceum. And next is New World cotton. Generally, the New World cotton is arose from the Old World cotton only. So generally, this New World cotton species are allotetraploids. Allotetraploids are nothing but these are the species which are having different different species. So they are called as allotetraploids. So these are having the chromosome number 2n equal to 4x equal to 52. Generally, in the New World cotton also we are having two species, that's the Gossypium hirsutum and Gossypium barbadense. So these are the two main groups of the cotton, that is Old World cotton and New World cotton. In Old World cotton, these are the diploids, and we are having the two species, that is Gossypium arboreum and Gossypium herbaceum. Next is New World cotton. These are the tetraploids which are having the chromosome number 52, and we are having here also we are having the two species, that is Gossypium hirsutum and Gossypium barbadense. And next coming to progenitor. Just now I told that all the New World tetraploid cottons were arose from the Old World cytoplasm. That is, here you can see this is the Old World cotton, that is the Gossypium herbaceum, and this is the Gossypium raimonde. This is the wild species. By crossing between the Gossypium herbaceum and Gossypium raimonde, they got the tetraploid cotton. So this is the genome, that is AADD. So this is about this. These are the progenitors of the New World cotton. That is the New World cotton means it is a Gossypium hirsutum and Gossypium barbadense. Next, coming to centers of origin. Here we are having in cotton we are having four different types of species. That is the Gossypium arboreum, Gossypium herbaceum, Gossypium hirsutum, and Gossypium. అరని పిలిచినావా నేను బంద్ చేసిన వీడియో రికార్డ్ చేస్తున్నా బంద్ చేసిన మధ్యలో చెప్పు ఉడక వస్తుంది ఏం చేయాలి సౌండ్ రావద్దు ఇంత ఘోరంగా ఉడకపోస్తుంది అసలు వేసుకో నువ్వు లేదు లేదు వేసుకో వెళ్ళాలి కదా, అందుకని ఒక వీడియో రికార్డ్ చేద్దామని అనుకున్నా. ఏది? ఇదా? అయిపోతుంది. 11:45 కదా. And next we'll discuss about the centers of origin. Here the Gossypium arboreum, that is, we are having the four different types of species in case of cotton. That is Gossypium arboreum, Gossypium herbaceum, Gossypium hirsutum, and Gossypium barbadem. Here the Gossypium arboreum, it is evolved from the Indus Valley of India and Pakistan, and then spread over the Africa and Asia. Next is Gossypium herbaceum. It was first cultivated in Arab and Syria. And next is Gossypium hirsutum. It is first cultivated in the Mexico. And next is Gossypium barbadens. It was the centers of origin for Gossypium barbadens is Peru. For all four different species, they are evolved from the different places. The Gossypium arboreum from the India and Pakistan, and the herbaceum was in originated from Arab and Syria. And next is hirsutum. It is in the first. It was cultivated in the Mexico. And next is barbadens. It is in the Peru. So all the four different species, they are having different centers of origin. Next, coming to the most important topic, that is about the breeding objectives. In the cotton, we are having the five important breeding objectives. The first one is improved fiber yield. Second one is improved fiber quality, and the third one is rapid fruiting and early maturity. And next is resistance to biotic and abiotic stresses. And the fifth one is improved seed quality. So here we'll discuss one by one. So first is the fiber yield. Fiber yield. Generally, the fiber yield in the cotton depends upon the number of bolls, size of the boll, and the percentage of the length. Generally, the plant should have more number of bolls. If the number of bolls are more, and if the size of the boll is big, and the percentage of length is nothing but this the removal of the cotton fiber from the seed is nothing but length. So what is the percentage of the length we'll get, that should be more, then only the fiber yield will be more. So the fiber yield in the cotton depends upon the three characters, that is the number of bolls, it should have more number of bolls, and the size should be more, the size of the boll should be more, and the percentage of lint also should be more. Then only the fiber yield is more. So the main character which is contributing more towards the yield is, that is number of bolls per the plant. If the number of bolls per plant is more, automatically the fiber yield will be more. So here high yield we can get from the more number of the bolls, bigger bolls, and the high percentage length. So the yield depends upon these three characters, that is number of the bolls, and the size of bolls, and the percentage of length. Out of three characters, the number of bolls per plant will be contributing the more towards the yield. And next we'll discuss how the length index and ginning percentage is calculated. Length index is nothing but it is a 100 seed weight. 100 seed weight is nothing but generally in bold seeds we will go for the 100 seed weight, like cotton, whereas castor, groundnut we'll go for the 100 seed weight. Like 1000 seed weight. 1000 seed weight or test weight is nothing but we'll go for 1000 seeds counting, like fine grain types, like that is short grain types, that is not like a paddy, rice, wheat. For that we'll go for the test weight, that is 1000 seed weight. So here the lint index is calculated as 100 seed weight by 100 minus lint percent into lint percent. And next is ginning percent. Ginning percentage is nothing but generally the bowl we'll be having the bowl, or within the bowl we'll be having four locules. In this locule we'll be having the cotton seed. On the cotton seed surrounding we'll be having the lint. So the ginning percent is nothing but it is a lint weight by seed cotton weight. Seed cotton weight is nothing but we'll be within the bowl we'll be having the lint weight as well as the seed cotton weight. So this the lint weight by seed cotton weight into 100 is nothing but ginning percentage. So these are the two calculations we'll do in the cotton. And next is bowl size. Generally, here you can see this is the bowl. Here you can see here we are having the 5, 1, 2, 3, 4, 5. 5 locules we will be having in this case of this picture, and here we are having only 4 locules. So those varieties which are having the 5 locules, they will give more yield when compared to those uh, those uh, those whole which are having only four locules. So we have to select the varieties which are having five number of locules within the bowl. And next is generally the cotton fiber is it is a very a lightweight. So generally we'll express the weight in case of grams in case of cotton. And next is the cotton seed. Seed cotton is nothing but it includes the lint weight as well as the seed weight. That is nothing but bowl size. And next is here you can see this is the in the textile industry after selling our produce cotton produce to them they'll do like this. Here you can see this is the one bale. One bale is nothing but the ginning. Ginning is nothing but the removal of the lint from here you can see. Here this is the lint surrounding this we will be having the seed. So the removal of the lint from the seed is nothing but ginning. So the textile industry they'll remove the lint from the seed and they'll compress that lint into 170 kg. That is nothing but bale. So in cotton, one bale is equal to 170 kg. To spun the thread, they remove the lint from the seed and they'll make into a bale. So in cotton, one bale is nothing but 170 kg. Next, coming to fiber quality. Fiber quality is nothing but it is how the quality of the cotton fiber it will decide. So generally in the cotton, the length is important and the strength is important and fineness of the fiber is important. The length should be to spun the thread. The length should be more. And next is strength. While spinning the thread, it should not be weak. It should be strong. So the strength should be more. And next is fineness of the fiber. The fineness of the fiber generally the thread should be fine. So then only the cotton generally the we can make the cloths easily. So these are the three characters which can be associated with fiber quality, that is length, strength, and fineness of the fiber. And whereas in the cotton, the fineness of the fiber is measured by the microneedle instrument. So these are the three parameters which are associated with fiber quality. That is the length. Length should be more, and the strength should be more, and the fineness of the fiber should be good. Then only the cotton fiber is will be considered as a good quality fiber. And next is rapid fruiting and early maturity. Rapid fruiting and early maturity is nothing but generally the cotton is an indeterminate crop. Means generally it will grow for some without considering the duration. The plant will have the vegetative growth and will be seeing some flowers, bolts on that. So to avoid that, we have to go for the we have to select the varieties which are having the early maturity. So if the maturity is early, we'll be having the less attack of the pest and diseases. And also if the maturity is early and if the maturity is at a time, we can harvest the cotton easily with a mechanical picker. But in case of cotton, because it is indeterminate crop, because we have to go for maturity is also non-synchronous. So because of that, in cotton we'll go for 4 to 5 pickings. So to avoid that, we have to select the varieties which are having rapid fruiting and early maturity. And next is resistant to diseases. Next, the fourth objective is resistance to biotic and abiotic stresses. And the first we'll discuss about the biotic stress, that is about the diseases. And next is we'll discuss about the pests. And then we'll discuss about the abiotic stresses. First, we'll discuss about the diseases. Generally, this disease is the biotic stress. Generally, in case of cotton, the wilt is a major disease. That is the fusarium wilt, which is a soil inhabiting fungus. The scientific name of this fusarium wilt is it is a Fusarium oxysporum fst vasi infectum. So this wilt is a it is a major disease in case of cotton. This wilt is mostly severe on the light and sandy soils. In light and sandy soils, we can mostly see this fusarium wilt, and this fusarium wilt will damages the tissues of the plant and causes the wilting and a premature killing. And generally, this fusarium wilt is associated with a nematode, that is a root knot nematode. The scientific name is Melidogyna incognita. This nematode will provide the opening to this fungus. Because of openings by the nematode, this fungus will enter into the root and it will cause the damage. That is nothing but fusarium wilt, and how this nematode is have the association with wilt. First, this root nematode, that is a Melodogina incognita, makes the entry for the fungus, and then from this, after making the entry by the nematode, the fungus will enter into the plant and it will attack the root directly, and because of this, it will causes directly wilting and premature killing of the plant. This is the major disease in the cotton, that is fusarium wilt. And next is insect resistant. In case of cotton, the pest is the major disease in the, major pest in the cotton. Because of this pest, there is severe losses in case of yield was observed. So to avoid that, we have to develop the varieties which are having more resistant to pests. But we are developing the varieties, but coincidentally, uh, we are not controlling this. Pest because continuously we are spraying the chemical insecticides. Because of this, the cotton insects are getting tolerance towards the chemical insecticides, and because of that, the cost of the insecticides are also more. And because of this chemical insecticide, this environment concerns and legal restrictions are also more widely using on this chemical. So we have to develop the, so we have, because of this insect pest, there is a severe yield loss in case of cotton. So we have to develop the varieties which are having more resistant, more cotton resistant varieties to the pest we have to develop. So during that time, they have developed the BT cotton. That is, these are the some of the these are the two major insect pests which are present in the cotton. That is a cotton bollworm. We are having three different types of bollworms. In that, these are the two severe cotton bollworms. That is the cotton bollworm, that is American bollworm, that is Helicoverpa armicera, and next is pink bollworm, that is a Pectinophoria gossypilla. Here, when they'll directly enter the bowl and they'll affect the lint. Because of this, it automatically, if they attack the bowl, the entire the lint will be damaged and they will convert into the. Here you can see the adult larva you can see here. After entering to the ball, it will eat completely, and the color will the discoloration of the lint you can observe. Because of this, the quality and yield will be directly lost because of this bollworms, that is cotton bollworm and pink bollworm. To control that, the BT cotton was introduced. That is, BT cotton is nothing but it is the Bacillus thuringiensis. The Berliner have coined the term Bacillus thuringiensis. He has isolated from a grain mill in the German district of Thuringen, and the first large scale BT product was released for release in 1957 by Sanda Corp. Generally, it was a BT variety, that is Kurosaki strain, where they have marketed it as a Turicide. So this is the history of the BT. Because of introduction of the BT, most of the bollworms were controlled, but some we can observe, that is Bolgard 1 and Bolgard 2, they have introduced by Monsanto company. Uh, so they have developed some of the resistant varieties, resistant, this bollworm resistant cotton varieties they have developed. So because of that, the farmers are getting somewhat better yield when compared to earlier because of this introduction of BT. And next is coming to the other pests. Other pests are nothing but some of the minor pests also severe in case of the cotton, that are nothing but the leaf hoppers, gases, and bugs. Generally, if the cotton plant is having more pubescence is nothing but hair on the leaves. They are associated mostly with the resistance. So we have to select the varieties which are having the more pubescence on the leaves. So this is about the resistance to biotic stress, that is diseases and pests. The diseases, the major disease is the fusarium wilt, and the major pest is bollworms, and the minor pest here you can see the leafhoppers, bugs, and next is those varieties which are having more pubescence on the leaves, that varieties we have to select. So they are having more resistance towards this minor pest in case of cotton. And next is drought and heat tolerance. That is the breeding for abiotic stress resistance. Generally, the water is the limiting source in case of cotton in dry, rain-fed areas. So during that time, the cotton yield will be affected. So we have to select the varieties which are having drought resistant, drought resistant varieties we have to select in the cotton. So these are the some of the five important breeding objectives in cotton. And this is the last one, that is the seed quality. Uh, generally the quality is also with yield and with yield and fiber quality. The seed quality is also important because uh, generally the gossypol content is a toxic component which was present in the cotton seed. If the if this gossypol content is more in case of seed, it causes the discoloration in cotton seed oil, and it will reduces the availability of lysine in cotton seed protein, and it also leads to toxicity to poultry because this seed that meal is fed to poultry. So because of this more gossypol content, it will lead to this three different types of causes, that is a discoloration cotton seed oil, and next it reduces the lysine in cotton seed protein, and next it is a toxic to the poultry because the seed meal is fed to the poultry. This this gossypol content more means it will causes a uh, damage to the cotton seed. And next is generally this gossypol content is are controlled by the two recessive genes, that is GI2 and GI3. So generally those insects have the preference for this glandless cotton. And next comment that is about the breeding objectives of cotton. And next coming to the breeding methods. So we are having the five breeding methods, that is introduction, selection, hybridization, mutation breeding, and heterosis breeding. Here we'll discuss one by one. As we know, introduction is nothing but directly introducing the varieties from different places, and by acclimatization or by primary introduction or secondary introduction, we'll directly release variety, or we'll acclimatize the varieties for some period, and then we'll go for cultivation. That is about the introduction. And next is selection. Selection is nothing but we'll be having the natural selection and artificial selection. Natural, mostly we'll go for the natural outcrossing. So we have, for this selection methods, we are having the three different methods which are widely used in case of cotton, that is a pedigree method, bulk method, and mass selection method. So these three methods used to handle the segregating populations. That is, this pedigree method and bulk method is used to handle the segregating population. So these three methods are used to develop the hybrids in case of cotton. And next is mutation breeding. When there is no variation was present for this traits, we'll go for the mutation breeding. Mutation breeding is not widely used in the cotton. Generally, this mutation breeding will be the natural mutations, or we'll be having the induced mutations, like we'll be having the physical mutations or chemical mutations. So this is about the mutation breeding. The mutation breeding is not widely used in the cotton. And next is hybridization. Generally, hybridization is used for hybridization is nothing but it is a crossing or mating between two genetically dissimilar parents is nothing but hybridization. This is the widely used method for developing the new cotton varieties. Because of hybridization, we can combine the desirable features from the different cotton cultivars. See, here in hybridization, we will be having two different types of hybridization. The first one is intervarietal hybridization, and the second one is interspecific hybridization. Intervarietal hybridization is nothing but it is a crossing between two different varieties is nothing but intervarietal hybridization. And next is interspecific hybridization. Interspecific hybridization is nothing but it is a crossing or mating between two different species is nothing but interspecific hybridization. So here you can see for intervarietal hybridization, we will be having three different types of hybrid, that is MCU5, MCU6, and MCU9. These two are the multiple cross derivative. And next is MCU9. This is the cross between MCU5 and MCU8. So these are the three hybrids of intervarietal hybridization. And next is interspecific hybridization. Interspecific hybridization is nothing but it is a, here first is the Gossypium. This is the genus and this is the species. And here this is the genus and this is the species. So the genus are similar, but the species are different. It is nothing but so the crossing between two different species is nothing but interspecific hybridization. So here the Gossypium herbaceum we have discussed earlier. This is the old world cotton, so it is also a diploid. So it is having the chromosome number 2n equal to 26. And next is Gossypium raimonde. It is an American cotton, that is New World cotton. Sorry, it is also American cotton. It is a diploid cotton. It is having the chromosome number 2n equal to 26. Here the genome for Gossypium herbaceum it is AA, whereas the Raimonde is 3D. So when we'll cross, we'll get the F1 hybrid with diploid diploid, that is 2n equal to x equal 26. So here will be the genome will be AAD. So generally the F1 hybrid is sterile. So to make it fertile, we'll go for the chromosome doubling with the calcium treatment. So, so here the chromosome gets doubled. So here the F1 hybrid is diploid. So it will be doubled by the colchicine treatment so that it will become the tetraploid. So here the opt-in species is Gossypium hirsutum, that is New World cotton. It is also called as amphidiploid allotetraploid. It is having the chromosome number 2n equal to 4x equal to 52. Here the genome is, here the chromosome is doubled, so here the genome is also doubled. Here AADD. So this is about the interspecific hybridization. And next is coming to breeding method is heterosis breeding. Generally, heterosis breeding is a widely used breeding method in case of cotton. In the world, the India is the first country to release the first commercial hybrid in the cotton. So we'll in cotton we'll be having both intraspecific and interspecific hybrids in the cotton. So for interspecific hybrid, we'll be having the H4 cotton. This is the first cotton hybrid which was developed and released in the country. And the main eminent cotton breeder is it is C.T. Patel. And next is interspecific hybrid. Here we'll be having the Varalakshmi hybrid. So these are the two intraspecific and interspecific hybrids you can see. And next here you can see the different types of cotton hybrids. Here the species are intraspecific hybrids and it includes the intra-hirsutum hybrids. And next the inter-arboreum hybrids. Here you can see the examples like H4, H6, H8, H10, Dhanalakshmi. There are so many intra-hirsutum hybrids are there, and here also we will be having some intra-arboreum hybrids and interspecific hybrids. In this interspecific hybrids, here intra-arboreum hybrids are LDH11, AAH1. And next, the interspecific hybrids, we will be having two different types of hybrids, that is tetraploid hybrids and diploid hybrids. In tetraploid hybrids, we will be having this Varalakshmi DCH32, NHP 12, and HB224 and DHB 105. And next is diploid hybrids. They are DH7, DH9, and DDH2 and PHA46. So these are the interspecific hybrids, and these are the intraspecific hybrids. And next is at ploidy level also there are different types of hybrids. We are having tetraploids hybrids and diploid hybrids. All intra-hirsutum and interspecific hybrids with Hirsutum and Gossypium verbalins are tetraploid hybrids, and all intra-arboreum and interspecific hybrids within Gossypium herbaceum and Gossypium arboreum are diploid hybrids. And next is hybrid seed production. We will be having two methods, that is a conventional hybrids we will be having and male sterility based hybrids. Generally, all conventional hybrids are, these are all the conventional hybrids. And next is male sterility based hybrids are Sununa PKV HY3 and PKV HY4 and MECH4 and AH1. These are the male stellate based hybrids. Based on the species involved, we will be having intraspecific hybrids and interspecific hybrids. And based on the ploidy level, we will be having different types of hybrids, that is tetraploid hybrids and diploid hybrids. And based on the method of seed production, we will be having conventional hybrids and male stellate hybrids. So heterosis breeding is the widely used breeding method in the cotton. This by using the heterosis breeding, they have developed the first cotton hybrid, that is H4, which was India is the first country to release the hybrid in the world for commercial purpose. And next, coming to institute, we are having the international institute as well as a national institute. International institute is, that is International Institute for Cotton, that is IICC, which is located in Washington, USA. And next is National Institute. We are having the two national institutes, that is Central Institute of Cotton Research CICR, which is located in Nagpur, Maharashtra. And next is Cotton Research Station, that is Junagadh Agricultural University, Gujarat. So these are the two institutes which are working in India. Whereas at international level, this is the IICC Institute, which is located in the USA. So these are the three institutes which are working widely for the cotton breeding. Next, coming to the summary, as the cotton is a vital crop because it is a commercial crop with a more significant economic importance. This breeding mostly will focus on the fiber yield and fiber quality and the breeding for biotic and abiotic stress resistance. And next is supported by the strong national and international research institutes. So this is about the cotton crop. Thank you.